Hi there, everybody. So some people were still doing 7, which is fine, but it's pretty much included in 8. So let's have our eyes this way, and we're all thinking, because, that's you too, Indy, because we can help each other out, even if it's like, yeah, I know what to do, but we're helping the whole class. So part A, find the parametric equations of the line passing through. So that's going back. What 2 things do we need to find the equation of a line? Yep. Direction vector. So we're going to find PQ, and I was about to make one up, but I think, well, do you know what? That doesn't take us very long these days to find a direction vector. Do we agree? So PQ will be 1, 2 take 1, 0 take 2 is 2, minus 1 take 4 is minus 5. Are we happy with that? Yep. We choose one of the points. P, go the first one, that's right, and that means, so I'm choosing the point 1 minus 2, 4. That means we've got equation of the line. The line PQ will be x equals, anyone? 1 plus t, that's a bit funky because they're both 1. It would be y equals minus 2 plus 2t, so minus 2 plus 2t, and then z will be 4 minus 5t. Do we agree with that? Now, you don't have to write it all down right now if you don't want to. We will be, I'll leave this up on the board, whatever. Okay, hence find where the line meets the YZ plane. Again, you're madly copying. I would say don't bother. Let's just have a look. I'll leave it all here because some people are not up to it, and I'd rather you are just thinking rather than copying. So where it meets the XY plane, we have got the XY plane. Do we agree that that would be this thing here? So we've got this line that's going into it. So similar to when we had where it cuts the y-intercept, the x-intercept, when it's it's going in here, what would be my y? Getting too carried away, getting a bit excited. What would be my x value when it's actually hitting there? So when it's cutting the YZ plane, it's basically code for you got to make x 0. So we look over at our equation, we're going, what value would make x 0? Huzzah, minus t. Okay, find where it meets, where the line meets the plane. So again, we've got y plus z equals 2. We can't help but want to sub. So we're going to sub in the y value, we're going to sub in the z value, and once again we will solve for t. Now part 3, it's pretty much the same thing, right? We are still going to sub. In place of x, we will put, so part 3, we will sub 1 plus t take 3 over 2. Agreed? This has to equal what, my friends? Minus 2 plus 2t, so I'm slapping in the y, plus 2 over 3, and it also has to equal, do your z bit. Now, that's excessive, right? You don't have to. I would go off and solve that one, but when I get my value for t, you must check that will work for that. It's like when we did the lines meeting, we did the x and the y, but then we had to check that it also worked for z. Does that make sense? They are nodding. As I said, I'll leave that and you can come and move it up, move it down. Yes?
I got that exact one, right? 3. Well,
He did.
I can work.
Find the foot of the normal. Do you remember what the foot of the normal is? Where it actually hits where the line hits the plane. So we want to find, we'll call that n for normal. No? The foot of the normal? What do you want to call it? I think they might call it n, capital N for the point and little n for the vector, okay? So what's happening here is on this line, somewhere on this line, we actually have this point. So let's say A A is here, 1, 0, 2. So, and we want to find this point here, N, on your norm. Any ideas? Yep.
What I was supposed to do is figure out the direction vector.
So figure out the direction vector, absolutely. So from here, we know the direction vector, which is our normal. What is that? 2, 1, minus 2. I mean, what is the foot there? Isn't it where the line meets the plane? And that's what you would have done in previous questions. So as you're getting to, we just have to find the equation of this line. What two things do we need to find the equation of a line? Got it. Direction vector. Got a point. So we can find the equation of a line. I'd do it in parametric form, x equals. Once you've got that, how do you find n where it hits the plane? Sub it back in. Like not so bad when we have a think of it. And, you happy? I'll just do this last one and then give you time to just play and I'll come and help. Have a read. Got a plane. Got a point. And we want to reflect it. So it's going all the way through. Yeah. So, what do we need to help us? Once again, yep, we probably want this point here, because would that not be the midpoint? Yeah. Midpoint? So, yep. So how do we find that? Well, just like we did before. We're going to find, once we find the foot of the normal, then we just do one more thing. And go, let's go midpoint, baby. See how you go. Happy with 11 or not? Who has done 11? So some people are not up to 11 yet. Great. So let's all have a read. So we want to just have a go and see if we can get started with 11, 12, 13, 14. So we're just making some notes so you can finish these at home and do a little bit more. So we've got a lesson tomorrow, so I know I'm not going to get too much time. But anyway, does the line passing through and which is normal to intersect any of the coordinate axes. So when we're reading this, what are we going with? Does this line intersect any of the coordinate axes? Now, we know if we had the equation of the line, how do we find if it intersects the...
Equated to a coordinate axis, like 1, like 0, 0, 0.
So when it intersects any of the coordinate axes. So that's when one's going to have to be 0. But the first thing you have to do is find the equation of the line. So we've got a point. It is normal to this. So in other words, we're saying that the normal of this is the direction vector for our line. Does that make sense? So we can at least find the equation of the line, think about what goes on next. 11, does the line passing through and is normal to, oh, that's what we just did. Sorry. 12, find the Cartesian equation of the plane, which is parallel to. Now, this is the one that I struggle with, just with the wording and to picture it. I've gone through this with you too. I started off trying to draw this, right, and go, oh, how do I draw something that's parallel to the x-axis? Now, drawing something that's parallel to the xy and all that sort of stuff, I can do that. But this has got a lot of different ones. But what's basically going on is we have got a plane. It contains A and B, right? And then because it's parallel to the x-axis, that means it's going to have this other vector that's got its direction vector here. That would be what? What would be parallel to the x-axis? So wouldn't it just be coming out like that? It'd be like 1. So that would have to be 1, 0, 0. Can you find the vector AB? So the vector between 2 points. Yes? So that means you're going to have to now go AB crossed with 1, 0, 0, because that's the one that we parallel to the x-axis, and then find the perpendicular of those two. Does that make sense? What point would you use to find the equation of the plane? Well, I'd go with point A. You do repeat the process, but in this time, what would be your vector that's going to be parallel to the y-axis? 0, 1, 0, and the z-axis 0, 0, 1. So do you have to do all three? Up to you. I'm going to go no. Maybe do A and C. I don't know. Now, 13, I am probably calling it now to be careful, because this is something that I could use as a test question. Have in the past, like when you go and look at previous tests, so I'm not telling you this is going to be in the test, but when I write it, this is an option for me. I'm telling you now, maybe I'll go, no, I changed my mind. But something simple like this would be state the, because these equations of lines, right? State the direction vector for this one. So I want you to think about, because they're going, yes, this is going to be x over 1, 1. So therefore, direction vector so far will be 1 equals y take 3 over 1. So far, 1, 1, all going very well. But now this has got the 2. So you want to rewrite this so that it ends up being equal to this. So do you agree this is z over a half, because 1 divided by half gives you the 2, plus, and that gives you 5 over 2 divided by a half, ends up being 5 over 2 times 2, which is 5. So this would actually be 1, 1, a half, right? Would I put that in a problem where it keeps on going and going? No, because then if you stuff it up, I have lots of different things that I have to mark. So that would be it. I'll show that or explain why it is. Or it could just be a simple question right at the beginning. State the direction vectors or state a point on the line. Does that make sense? So do be careful with that. Anyway, let's go back. Show that these lines are coplanar and find the Cartesian equation of the plane. What does it mean to be coplanar? They lie on the same plane. So we've got these lines happening here. And they're not skew. Why aren't they skew?
Since they're lying on the same plane.
Yeah, because for them to be skew and not meet, then they're up a little bit. Could they be on the same plane and be parallel?
Not really.
So could it be there and there? I mean, it could be, but how would we prove that they are or they aren't?
Direction vectors.
Your direction vectors. And so what's the direction vector of this first one? 1, 2, 1. They are not multiples of each other, so they are not parallel, and we can also rule out coincident, correct?
Yep.
So one of the things that we can do is, we were talking about, you could prove that they intersect, find that point and get the plane. We were a little, Sam and I were chatting, we're like, not really proving, like you can find the equation of the plane, has it proved that they are coplanar? Anyway. Carrying on. So you need to make any notes at this point, or are you going to use my notes? I mean, they don't look overly helpful, so you might want to add little bits and pieces and notes on your, I'll try and be better. Can you please read 14? That was probably like a minute for them to think. Who is unsure of where to start for this one? So again, I would start by drawing a diagram. My planes always seem to sort of be the flat like that. I should try and draw them the other way. Might have to get Miss Pat in here to help us with the 3D stuff. But anyway, A lies on the plane. So A is right on the plane. So how are you going to find K if it lies on here? Special K, don't tune me out. Huh? That's your X. That's your Y. This is your Z. What? Just sub it in. Absolutely. Sub it. Sub it. Okay? So we're going to sub. And we should be able to find K. Agreed? So now we know this point is 1, 2, I will tell you now, I think it's a fraction. It's either 2 over 3 or mine. Have you done it? Negative 3 over 2, right? And so now we have, find B is 6 units from it. Now B could be 6 units this way. But could also be 6 units this way. So how are we meant to find the coordinates of B? And the whole point is 6 units. Yeah. Well, you chuck out distance formula, but what exactly are we putting into the distance formula?
Oh, B.
But I don't know what B is. So people are going, just put BA, but I don't actually know what B is. Now, if you put, let's just call it X, Y, and Z, you've got 3 unknowns, and that's no good. So it would be handy if we could express B as being any point on this line. Do we know how to find the equation of a line? Yes. What 2 things do we need? Direction vector and the point. Now we've got the point is 1, 2, minus 3 over 2. What's the direction vector of that? It's the normal, that's right, which is 1, 2, minus 2. So you're going to find the equation of that line, and therefore, so let's say the equation of the line, so e.g., this is not the equation of the line, but just imagine it's x equals 1 plus t, y equals, I don't know, minus 2 plus 2t. You get your z. Yep. You're going to have to go that, take this point, all squared. This one, take this point, all squared. Your z1, take this one, all squared. You can say square rooted equals 6, or you could just say equals 36, and then you have to solve for t. Does that make sense? I'll write a little note here. Eager beavers ready to go. Packing up, like they're on home and away. Sorry, mate. So this is not the line, we've just made it up, right? So then you're going to have to go that, take that, yep, and we're going to put it into our distance formula. So it's going to be 6, and I'd probably go 6 squared equals 1 plus t, take the 1 there, all squared, plus, and again, I've just pulled these out of thin air, so don't take it as gospel. You would have your own, right? So then you're solving, I haven't put the square root because I squared here. I've used my distance formula, and then you just have to solve for t. Now you should have 2 values for t, obviously, because one is going to be 6 units up and one is going to be 6 units down. So hopefully that gives you enough to get up to and finish at least 14. Cheers.